So now we're going to start talking about Newton's second law. Newton's second law is simply F equals ma. This is by far the easiest of Newton's three laws to remember and very easy to apply, okay? But I'm going to use a question in just a bit to help illustrate how we can apply this equation and this law to a real MCAT problem. And I'm going to use it to help give you some exposure to the kind of intimidating and superfluous information that the MCAT is going to throw at you. They love to throw you in unfamiliar situations, even while testing you on very familiar basic science topics. So this is something that I want to give you a lot of exposure throughout the program so that you can be prepared and ready for the type of critical thinking and the problem-solving skills you're going to need to apply on test day. That's going to be one of the most important goals. Is not just sharing information, but teaching skills. So we're going to go ahead and practice that skill together on a problem I'm going to pull up just now. So this question here is a great example of Newton's second law and how you are likely to see it tested on the MCAT. Go ahead and give this a shot, and we'll go ahead and talk about it when you're done. Be careful about the units you're using. Make sure that newtons, which is your units of force, are always measured in kilograms, meters per second squared. Units of acceleration, and the SI units for mass, okay? If you're not using those units, you will get the wrong answer. So now let's go ahead and go through this together. Okay, so you can see we've got a lot of information in this passage to get through. Skim over the passage, get an idea of what's going on. Don't worry about all these details. We'll come back to them if we need them. Let's go ahead and skip right to the question. So what was the acceleration? Well, the first thing I'm going to think about is, okay, what can I use to find acceleration? And right off the top of my head, there are a few things that come to mind. I can think of x equals 1/2 at squared. So if I know a distance, if I know a time, I can find my acceleration. I know general equation, change in velocity over time equals acceleration. So if I have a change of velocity in time as well, I can find it. And then most basically, we have F equals ma. So all these equations will work. These are some of the first things that come to my mind. There may be more ways to find it, but let's go ahead and start here and see which ways work. So let's go ahead and scan the passage for information that we can use to apply with this first equation. As you can see, we've got a distance, 2 centimeters over here. Now make sure that if we are going to use this equation, that you convert that into meters, SI units for displacement. Okay, but now let's go ahead and look for a time. You should notice we don't have a time, so this equation is not going to work for us. Now change in velocity down here. We do have a change in velocity, right? But once again, we don't have a time, so this equation is not going to work either. So we are very quickly running out of options. But let's go ahead and check out our last one. F equals ma. Okay, we've got a force up here. So that's the repulsive force that these two electrons are experiencing. They will both be experiencing it equally. So that force is the value we want to use. And then let's see, do we have a mass? Perfect, we do have a mass. 1.1 times 10 to the negative 26 grams. And that should be something that you pay very close attention to. Notice that it's grams there, and make sure that you convert it into kilograms. So we've got I'm going to say 5-ish, e to the 2 newtons, and that's going to be equal to our new mass, which is 1.1 e to the negative 29 kilograms, and all of that times acceleration. So that gives us 5.5 e to the 2 divided by 1.1 e to the negative 29. At the end, if we do that math, it's going to give us 5 e to the 31 meters per second squared, and that is the correct answer. So great practice walking through a tough practice problem with a lot of intimidating information and a lot of extraneous information that you really don't need to know. But this is very typical of the MCAT and something that I'm going to give you a lot of practice on as we go through the program.